it's hard, like it's like an engineering or it's maybe even a research question, how to incorporate this data in the model without losing information from before. Okay, so these models have this problem called catastrophic forgetting, and it's a thing that happens over the course of training. So if you train a model on like one data set and then you get a new data set and train the model on the new data set, it forgets the information in the old data set. It's for some reason that people don't really understand. So
how can you not understand why? I don't know.
The model has like a trillion parameters. It's just like not at all obvious what it's doing. Have you seen these like programmable boards? There's like a board that like you buy it from some company and they have like specific.
It's like this on you put it in your house, right?
You can put it in your house, and everyone who buys it builds it in exactly the same way. And the holds have LEDs on them.
Got it. Yeah.
And then there's an app, so you can like turn on a certain set of lights, and that is a particular climb.
Nice.
And so there's one of those in the gym, and it's like extremely difficult. And so we're trying to get better at that one. It's like very good training tool.
That's cool.
Yeah.
I mean, speaking of training, I think a topic that's on all of our minds. I mean, part of the reason we wanted to have you on is just to demystify some of this deep learning, neural nets, all that stuff. Akshay is one of the few people we know who is quite deep in the learning. And so to kick things off, maybe you can just share a little bit about your background. How did you get into, I know you've been, in engineering for a long time, even since college, but how did you end up forging the path towards, machine learning?
Yeah, that's a good question. So actually, I think when I like applied to college, I was like debating between doing like bioengineering and computer science, because somehow I like even younger, I like really like marine biology and these kind of things. So I was like, maybe that's a good path. And it seems like interesting stuff going on there. I ended up doing computer science just kind of randomly. And I liked it, but then I like started doing research in computational biology, like using computational tools to solve biological problems. And I actually applied to grad school to do, maybe let me back up. I think somehow at some point I like imagined I would do like a startup. That would be my like course after undergrad. And like, me and Arvind would like build these, do these hackathons and stuff together. And so that was sort of like the path I thought I was going to be on. And I did some like internships at like tech companies and like smaller tech companies. And I thought it was just like actually insanely boring. So I didn't want it. And that's not to say the companies are boring. It's just like what they offer the intern is kind of boring, right? Like the interns get the stuff that no one else wants to do, or that's not a high priority, right?
Where were you interning?
I interned at a company that actually Microsoft bought. It's called Tell Me Networks. And then I interned at VMware.
Got it. I guess. And you were coding. You were doing like software projects.
Yeah,
right?
I was doing, But like they sort of have you do like internal stuff, that's like just something that some engineer doesn't have time to do, that they're like, yeah, we'll just get an intern to do it kind of, so it's like
totally
the most interesting thing.
And that was at a time when VMware was pretty hot stuff.
It was like,
eventually got acquired, and it became a really big company and got acquired by EMC and stuff like that. But then at that time, it was a really hot company to intern at.
Yeah. So like when I was there, basically like my team would play like foosball for like 2 hours a day, which was like not, okay, that's fun and all, but like that's not like what I was like imagining I do for the rest of my life, and this includes like the full-time people. So it's just like not, anyway. So anyway, I was not that interested in that. So then I decided maybe I should do research, and I applied to grad school to do like computational biology. And I interviewed, like I got into some places, and you go and you visit the place and you talk to like the faculty who are interested in like working with you. And I decided I was not interested in working with them, because like computational biology, it seems like they're more interested in like what are the biological findings and less interested in like what's the like computational methodology, right? So if doing very simple things can lead to interesting biological conclusions, they're very happy, right? But that somehow did not interest me as much as like coming up with new methods and designing algorithms and stuff like that. So then
what is that for, what does that mean, coming up with algorithms? Like, what does that even mean?
I will get to it, I guess. Maybe
okay.
Maybe like there's some like, so a lot of these computational biology problems, you like run some experiment and you collect a massive amount of data, and you have to do some like data science or modeling to like extract conclusions from like a enormous amount of data.
Yeah.
You can't just like look at it and eyeball. It's like, I sequenced the genome of every cell in your body. So this is just like a huge amount of data, and I want to understand if you have some disease or I don't know, something like this, right? And maybe like there's a simple thing like I do linear regression and I can figure this out, right? That's somehow like less interesting to me than like coming up with a good model that like doing some, you know, trying to like extract more structure in the data sets and stuff like this, right? So that's the kind of algorithms I was thinking about, like I found more interesting. And I guess I found this is basically what like machine learning people do. They like just design the algorithms and they're not so attached to a specific problem domain. So I decided to do that. And so, yeah, I went to grad school in machine learning, and I was very interested in these like problems where you can like, or the learning algorithm or like the AI can decide what data to collect. So maybe there's these situations where like I can choose where I should make a measurement of a system. And by doing so, I can use my measurements very efficiently and extract the information I need to extract by being very deliberate about where I make measurements.
Can you give an example?
Yes. Well, I'll give you two maybe. So one that like is kind of related to something I worked on in grad school is you're trying to measure like examine a lake for like pollutants. And you can like drop like a probe into the water and like collect, you know, get some information about what the water is around that location. But maybe instead of just like throwing probes randomly, you should sort of like throw a few probes and then see where there's some signal and then like throw more probes closer to where there's more signal. You should sort of like localize to where you have information. So you should do this in some like multi-stage process where you take the information you get from like the first round of measurements and you use that to decide where to make the second round of measurements. I think this is basically how like any human would do this task, but it's actually like not the way that a lot of like algorithms would do it, because there is some overhead to like multiple batches of measurements and stuff like this, right? So that's one. That makes sense?
So just, sorry, you were trying to figure out how to tell the algorithm how to take the next set of data points, like using an initial set of data points, how can I optimize where the next set of data points goes?
Yeah.
Okay.
Yeah.
It sounds like very statistical.
It's very statistical.
Okay.
Yeah. And this will sort of like, it depends on like the structure in your problem. Like if you imagine that the pollutants like they stay in a little, you know, they stay close to each other. They don't like just diffuse arbitrarily, right? So there's you have to like account for this. So like if you imagine the structure looks like this, then maybe this is how you should design the measurement scheme. Okay. The other one is closer to like what I work on now, which is, and maybe what is like hot these days, which is like reinforcement learning. So reinforcement learning is a situation where there's an agent and the agent sort of like interacts with the environment to collect information about the environment, right? And like what people are using this for now is for building these like reasoning models. So like a reasoning model will like try an answer and like see if it's correct. And based on whether it's correct or not, it will try another answer to a question. And ideally, you should like use the information about what you have seen in the past to like be more strategic about what answers you're trying. You certainly shouldn't try the same answer twice, but maybe you also shouldn't even try like related answers, whatever that means.
And what feedback, what's the source of truth for telling it did well or not, typically?
Yeah, so that's a good question. I think what's going on a lot in like generative AI these days is you will take like a data set of curated math problems where you have the question and the like numerical answer to the question. And the feedback is like the agent reads the question, writes down some computation that it's trying to do to solve the problem, and then writes down its final answer. And you just check, is the final numerical answer the one that was in the data set? And you reward the agent for getting the answer correct.
Got it. I've heard like, you know, let's take YouTube, for example. The way that they do this often with video content is to delete a bunch of pixels in the video. And then they know the real video content. And so then they'll have the algorithm guess at what the video replacement should look like to make it sort of, and is that, I don't know if that's the way I mean, I'm guessing with text, the way they often do it is they'll have it guess the next word. And then they'll sort of look at the probability that it was right based on real text databases that say this often was the next word. Yeah. Is that right? Okay.
Okay. So I wouldn't call this reinforcement learning, but it is also what is done. Both of these.
Okay.
So okay, now we're going to get into
it's fine. Let's get into it.
Yeah. Okay. So a language model, which is like what GPT-4 is and whatever, Gemini. the first stage of the language model is what you just said. You like collect all the data on the internet, and you train like a neural network to take like a sentence and take the first 10 words in the sentence and try to predict what the next word is. And you have the full sentence. Okay.
Yeah.
And you just do this on like the whole internet with a massive network, and there's lots of tricks and stuff that you have to use, but this is like morally what is done, right? And you train it in some like probabilistic fashion. So like the model outputs a distribution over what it thinks is the next word, and you want that for the true next word, the probability under my distribution is very high. Okay. So this is like, that's called pre-training, I guess. There's many interesting things that go on here. So one, actually people don't just take all the data on the internet. They're like very careful about curating data. They also do this like synthetic data thing. So you can like adjust the pre-training corpus by carefully asking like GPT-4 questions and getting the answers from GPT-4. That's text. So you can generate data to be used for pre-training.
Isn't that just double count? Like, how is that new information though? Isn't it because it was generated off of an old corpus of curated data? Doesn't it just end up like mathematically being somehow the same information? Like
it's not new information. I agree. Yeah, it's the same information. Well, okay, so this is the thing that like competitors are doing to try to catch up.
But you can't accelerate beyond someone.
But maybe you cannot accelerate.
Okay, so this is maybe like how DeepSeek gets better faster, is they look at someone who's already gone there, train off their outputs.
In fact, I guess I heard there's a lawsuit because OpenAI is claiming that DeepSeek did this and suing them for it.
And the irony, of course, is that OpenAI trains off of written word by New York Times text or whatever.
Yes.
Reddit.
Yes, exactly.
Got it. Yeah. So they don't really have a leg to stand on, but at the same time, this is why like follow-on competitors can go faster. Is their synthetic data is curated, is pre-curated sort of by these other.
Yeah. So there's still some. I mean, it's like a non-trivial thing. You have to figure out like what questions should I ask GPT-4 to get it to generate good answers? Like you still need to say like what is the data mixture? Like how much should be math and how much should be physics and how much should be literature, right? And amongst the math questions, like which ones should I ask, right? So there's some non-triviality here, right? There's also like a scaling because GPT-4 is expensive to do inference. So you can't just like ask it all the questions in the world. You have to be like, which, I don't know, 100,000 should I ask or something, right?
Can I ask you one other?
Go ahead. One other quick question on this, which is, if you're an early to market model like GPT-4, let's say, and you have a lot of user base, how much are they benefiting from people typing in like natural language questions into GPT-4 and getting more and more training data from people interacting with the system and then giving it feedback? Like if I ask it a question and then based on what it responds, maybe it can tell by my follow-on whether it was right or wrong, or if I've asked it to correct. Is that part of reinforcement learning as like a second phase?
Yeah, so that's more the like reinforcement learning part. I don't exactly know, but I heard that they're actually not using this data at all.
Oh, really?
Although they collect it.
Okay.
Yeah.
Although it seems very powerful.
Wait, so you're saying that they're not using the data that you and I are using GPT? We're asking it questions, they're not using that. But wouldn't that be so? Like, wouldn't you need to, if you're OpenAI, you want to use that so you can figure out what to train on? Because if you have an area that's being asked a lot of questions and you don't have the results aren't good, you want to make it better, right? Kind of like Google, right? Like Google will use the search logs to figure out, okay, what's trending, what's the most important stuff to get right, and do a better job, right? So like they probably are doing that, or you're saying that?
Yeah. Not. So I mean, I don't exactly know. Maybe I'm saying I don't know the extent to which this is automated. I'm sure they're like looking at the logs and trying to figure out where people are upset with their model and stuff like this. Yeah. And then, but this might be like there's some human in the loop, right? Human is like, oh, like they ran some script and the script says like, oh, you need to put in more math knowledge or more knowledge of convex optimization or whatever. And then they go back to the team who works on the pre-training and they say like, hey, can you generate more data on convex optimization?
Yeah, presumably that's why they're hiring people.
But what did you just say though? So what did this word you just said meant? And is that related to what you research, convex optimization?
It's just some math topic. It doesn't matter.
No, so that's like getting to the bottom of the gradient function, basically.
Yeah, exactly.
Like, okay, of this. Okay.
Yes.
So
that's just some random math topic. It doesn't matter. Yeah.
No, not that it doesn't matter. I'm interested in the fact that that's like the thing that your brain goes to is like, that's probably what they're doing. Whereas Vivek and I are like, what the hell is that?
Yeah.
I'm out in left field over there. Arvind knows some of these words a little bit.
I know basically what you're getting at. Okay, can I ask you different? Maybe we don't need to rabbit hole on that, but why not have like an interaction like a like button or something where I'm surprised they're not
They
trying
do
to
have
get
that.
more.
They do have that.
Oh, they do
They do
for
have it.
response.
They have
do
it
have
thumbs up,
Okay,
thumbs
okay,
down.
they have it.
But
Okay, I didn't know that.
in the UI, it's not particularly huge, but you can thumbs up and thumbs down things.
Okay, okay.
And
So,
also,
yeah.
I when I was at Notion, they integrated GPT, and Notion in their iteration of using it in the Notion product, you could thumbs up and thumbs down answers there too. So I don't know if they were sharing that data back or if they were just using it internally to optimize. But but that's a part of it.
Yeah.
So maybe to ask you a question that's like maybe productively rabbit holing off that convex question, which is what do you
Productively rabbit holing. That's
Yeah.
the name of the pod now.
Yeah.
Yeah, that's a good. This pod specifically should be called that.
Productively rabbit holing. Yeah.
What is your research looking at right now, like in relation to this? And I know you do a ton of math, so like I know that's a large part. I think you often say you don't really code even at all. But what is it in relation to this? Can you explain it? How does it enhance this or not?
Yeah. Let me try to answer the previous question. So these models are collecting this like preference data. So like sometimes you ask GPT a question, it will generate 2 responses, and it will say which one do you prefer, right?
Uh-huh.
Yeah,
think
they had that for some time.
So they have that sometimes. So for that, it's like kind of clear what a good answer is. There's just an issue of like, okay, it's hard, like it's like an engineering or it's maybe even a research question, how to like incorporate this data in the model without like losing information from before. Okay. So these models have this problem called catastrophic forgetting, and it's a thing that happens over the course of training. So if you train a model on like one data set, and then you get a new data set and train the model on the new data set, it like forgets the information in the old data set. It's for some reason that people don't really understand.
Okay.
So they don't.
How can you not understand why? I don't know.
The model has like 1 trillion parameters. It's just like not at all obvious what it's doing. Right.
So we see it in the outcome that it's somehow forgotten.
Yeah,
Like-
you'll see it in the outcome. Yeah.
Okay.
So
Okay.
you can do these. Actually, my coworker did these experiments before on like can you tell if there's cats and dogs in these pictures? Like some very simple problem.
Yeah.
And he sees that like if you train on like half of the data set, you get like good performance on. Okay, maybe there's like 2 parts of the data. There's like cats and dogs at night and cats and dogs in day. If you train on the cats and dogs at night, you get like 90% performance on the cats and dogs at night. If you then train on the cats and dogs in day, you like lose performance on the first and you increase performance on the second.
Mm,
But if you train on like a mixture of them all at one time, you get like good performance uniformly.
so there's some like recency bias to the models.
Exactly.
Okay.
Yeah.
Got it. Okay.
Yeah. So there's this problem that like maybe you want to incorporate the information, but you kind of don't know how. Like
Mhm.
it's
Mhm.
there, it's very explicit, but like I don't know how to do it. Right?
Will you overshift the parameters in some way that's not
Exactly.
desirable? Got
Yeah.
it. Okay.
So one thing that they might do is in the next like full training run, like when they release GPT-5, they'll use all this preference data from before because
Mm,
they kind of are doing that anyway in like phase 2 of the language model training. They're using preference data to like align the model. So they might use it in GPT-5, but they're not doing this like feedback loop where they're continuously improving the model due to this like catastrophic forgetting issue.
Interesting. Yeah. I mean, that kind of makes it feels analogous to humans even. Like if
Yeah.
I learn something after I've learned a different thing before, I'm going to be more preferential to the thing I've recently
Exactly.
learned. Yeah.
Exactly. Yeah. Maybe let me make one more point about this. The other issue is a lot of times it's actually not clear what the reward signal is. So if you get this very, I think it will be a bad UI if every time you ask GPT a question, it gives you 2 responses, right?
Yeah.
Yeah.
And they ask you for a thumbs up, thumbs down. So sort of what they want is like just through the course of you talking to it, it infers if the conversation is going well or poorly. But this is actually kind of a hard problem, right? Like
Mm.
you and I have a conversation at the end, like, was it good? I don't know. Like sometimes it's just like very hard to tell. So there's some question about like was it good or bad afterwards, right? And there's,
Yeah.
you can come up with stories about like, oh, I can tell in this case, but like you need to do this at massive scale automated. Right.
Yeah. Yeah. It's one
So,
interesting
like,
thing.
yeah.
Like we record these episodes, then we post them online. we're getting some sort of like viewer click-through feedback a little bit on like,
Right.
but some of that is also mixed up with SEO. Some of it's mixed up with like, has our audience matched?
It's like
the
99%
conversation
related to who it's shown to by the algorithm, right?
Right. And
Right.
so, like, to your point, it's like if we even indexed it off of feedback from that, we'd be getting the wrong signal, maybe on how interesting was the conversation or something. Like, that's not necessarily related, or how correct were
Right.
the answers or whatever. Yeah. So it's interesting. Like, how do you judge it?
Yeah. So you're totally right. This is a problem that all the big tech companies have. And like, I think, I don't know, 40% of Microsoft engineers are basically working on this. They're like, when you like, how do I measure if things are going well in my system from interacting with users? Right. And like when we did search or when we do personalization or stuff like this, there's some team of 20 people who are trying to figure out what this is. Right. But I think for just free form text, it's much harder. So it is a problem that people are like in the high level people are working on, and there's a lot of ways to do it, I guess. But I don't know if it's being incorporated for text, like just for like general, free form text.
So maybe to take a quick step back for those who are not as deep in the research,
we really dove right in.
I guess there seems to have been a bit of an inflection point at some point, and it occurred to me that in your experience, you sort of saw the pre and the post of the performance of these models, how they've been commercialized, et cetera. Can you talk a little bit about that? Like what has happened in the world of machine learning that over the course of the last, I don't know, call it 10 years, that is sort of, we've seen that monumental shift, and now, everyday people are leveraging this day to day.
Well, I don't know how to answer this question. Okay, I guess you're not talking about like DeepSeek as a tectonic shift. You're talking about like
No, not DeepSeek.
The GPT moment or something.
Yeah, I'm saying
Right.
like the moment. Yeah, like the GPT moment, honestly, because OpenAI was first to market with it, right? So
yeah,
what caused them to be able to get to a point where, this was now a viable product that could be used?
What was the technical unlock? Is kind of what you.
Yeah. What do you see as the reason why there was this, I guess, inflection point in how all this kind of turned out?
I'm actually not sure if it's like, okay, like I guess what people say is it's just scale. So like, I think if you look in the history, there was this progress. So like, there was this breakthrough of doing really well on this image data set that in like 2015, that was like, and this was basically take like a very standard deep learning model and just like train it in the standard way on a lot of data. Maybe the model has to be big, so like, and then there was like GPT-2, which is like a kind of reasonable like language model, but it's very small and not trained on all that much text. Then there's GPT-3, which is a bigger model trained on more text, so on and so forth. So I think, how did you get to GPT-4? There's a lot of details, but like the bigger picture is there's scale. That the compute is high, the model is large, and the data is large.
And can you talk a little bit about like, it seems like the things that kind of coincided to make it happen was also related to, and I remember this from, I used to work at a company called Blackbird that was doing kind of the early days after the 2015 image stuff came out. We were working on image recognition and commercializing that in some way. And so I guess, can you talk a little bit about how the hardware also got to a point? It seems like the NVIDIA GPUs was kind of a big breakthrough too, outside of just kind of the machine learning and the software side of things.
Yeah, but I don't know much about it. I guess the hardware is like, you cannot train a big model without good hardware. That's my like,
Because like my understanding was, I mean, you were working with this stuff. Like, was there a point at which that someone realized, oh, you can use, NVIDIA GPUs for this, or was that always part of the mix of tools you had?
I don't think it was always part of the mix. So somehow, like, okay, like the longer history is like these neural networks are very popular in like the 60s and 70s and 80s. And then there was this belief that they would never take off. So there was this like AI winter and like the rise of convex methods, okay, which are not neural networks. And then like in 2010 or so, they started slowly coming back into fashion. And this is, I think, in part because of the improvement in computational tools, right? Like both, like, I don't know if you've heard of like PyTorch. PyTorch is like a library that's part of Python that's like for training deep models. And because of like more like larger data sets, better just like CPU and GPU infrastructure and stuff like this. So this deep learning stuff kind of didn't work when you don't have good compute, good hardware. And now that we have good hardware, it like started to work. And basically the believers just kept pushing, which is good. But like all these other people were kind of like haters and started doing other things, right?
What
And
was the original belief based on? Was it that you wanted to mimic a biological brain
yeah,
and that would probably be the best model?
I think so. Yeah.
Do you still believe that? Like, do you think personally that that is the best way to artificial intelligence?
I think now it's maybe not for the connection to humans, but it's more like the models are co-evolving with the current hardware.
Let me,
like,
can I ask you a different way?
Yeah.
Which is, do you think that if you put a set of like neurons together at a large enough scale, and by neurons I mean like nodes that are connected to other nodes that are sending signals back and forth, that you emerge intelligence out of that setup? Is that like an emergent property of having the type of information flow and connections and then reinforcement that you're talking about?
I'm not sure. I don't exactly understand the question. I think for this, like you need some external signal. The neurons cannot be in a vacuum. They need to like interact with the world in some way.
Yeah.
And like some of them need to like acquire information about some sensory experience and then propagate it to the rest of the neurons, right?
Mhm.
I guess in some sense that's like what's happening in these models. They're like acquiring like the top layer neurons are acquiring information about like which word comes next and then propagating that down to the other neurons, right? I can imagine that this is basically true, but there's a question of what scale, right, in some sense, right? So like maybe you need like exponentially many more neurons to do it if you have a bad architecture than if you had a good architecture. And that will make a difference, right? Like even though everything is growing, you're not going to reach an exponential if the gaps are, So maybe these things matter. Like this transformer kind of architecture is like very good with the GPU hardware, stuff like this.
Can you describe what your research is on?
Yeah, okay. Now I can do this. So now like I also work on language models. I mostly work on the second stage, which is called like post-training. So okay, so now there's pre-training, there's post-training, and then there's like this new thing called inference time compute. So post-training is like you have this pre-trained model, it's kind of like good at producing text, I guess, but you want to like get it to be good at following instructions, and you want to get it to like not produce the toxic content that it found on Reddit, which it read and it learned about. Let's say you trained it on all the internet, it like knows a bunch of things you probably don't want it to ever say, right? So this post-training phase is like you try to do this stuff. You try to get the models to be better at instruction following, and you try to get the models to align with human values. And so I work on this. This sort of like you take a pre-trained model, then you like do some stuff and you like train it a little bit because you don't want to do this catastrophic forgetting. You don't want to hit catastrophic forgetting. You don't want to train it too much. You train it a little bit. Okay. And there's a bunch of algorithms that people use. They're basically all of the top labs have like some battery of like 25 algorithms that are all doing slightly different things, and they run all of them here.
Okay, so I'd imagine you have some curated data set that you train on, and then that's like reflective of the values. What are some of the challenges you run into with, or that you try to overcome with your research in this space?
Okay, this is a bit technical. Okay, so I'll tell you one problem that people run into. So it's again, so one way that people align, because it's actually hard to get humans to elicit what their values are. You collect a data set of preference data. So you give the model like some question, and then have it generate like two responses, and then you show both responses to a human, and you ask the human which one does it prefer more. Okay, and then you like so you get this data set of like here like these paired responses, and that one is better than the other. And what you try to do is you try to like tilt the model to prefer the one that is preferred, and you try to do this without moving too far away from the base model, the pre-trained model. Okay. So let me tell you one way in which this is actually done. So you train a reward function that like scores the responses. It just assigns a numerical score to every response, and you train it so that the ones that have the ones that are preferred have higher scores than the ones that have a negative score. And then you train the model to produce responses that have high reward according to your reward function that you learned. It seems very natural. Okay, so what happens is the reward function is sort of like only good on like near the data that you collected, because it's a trained machine learning model. So if you like produce responses that are like out of distribution or very different from what it's seen before, it's not clear what score it's going to give. Your language model is trying to get high reward. It's actually incentivized to go out of distribution to produce things that the reward model has never seen before, that it happens to give high reward. So there's this phenomenon that is well documented. It's called over optimization. The model, when you do this process, the model over optimizes and produces things that get high reward according to the reward model, but are actually bad.
Yeah, it's like when someone who's like wants to get a girl and they're really rich, they just try to throw money at the problem, but then it doesn't work. It's like
exactly yes. It's a mismatch between like the thing you can measure, which is like the reward according to the reward model, and like the actual thing you seek, which is like alignment to human values.
Yeah.
Right. And so when you there's a name for this phenomenon. I forget the name. When you try to optimize the thing you can measure, that is a surrogate for the thing you care about, things always go wrong. You always over optimize. So this is the same phenomenon that happens here. And you need to do something to like prevent the model from over optimizing. So we have a paper that does this, I guess. There's a new technique, a new training method that like forces the model to stay close to the pre-trained model in some way, so that you don't wander too far away and like produce bad stuff.
Can you put all of this in context of like the guy trying to get the girl analogy?
Yeah, maybe the idea is like I'm allowed to change myself in some way, but like not that much. That's the idea. It's like you can't go like off the rails optimizing for money, or you can't go off the rails optimizing for like your strength, or like you're like, I am who I am, and like presumably that's like reasonable at attracting women or something. And I should only make small changes, because if I over optimize on any of these things that I can measure quickly, I'll like, I don't know, become a lunatic or something, like
it's lucky the three of us are already married. I feel like we'd have no chance at finding someone at these conversations. So can I just ask, like, how do you approach solving a problem like that at work? Like, is it like you're looking at sort of a mathematical formula and then trying, like, I don't know, I don't even know how to think about what you're working on practically.
Yeah. So I guess there's two parts. So one part is actually just like having context for what are the like open problems in the field. So what are things that people find that they don't seem to know how to solve? And one issue that we saw was this over optimization phenomena, was something that many empirical papers seem to have like observed, but they don't seem to have like good solutions. Like, or all the solutions they have seem to be very like, I don't know, like kind of hacky and stuff like this, right?
So the problem practically for over optimization, like we said before, is that if you overdo it on one certain parameter, it kind of goes away from the ground truth of what you're trying to actually get at.
Yeah.
Okay.
Yeah, and I guess, okay, so when you say it that way, it's somehow like very obvious, right? Like this seems like obviously true. The main thing is like in language models, it's actually kind of like fundamental, because the space of possible responses is so big. You cannot hope to ask humans which, like, are all of them good, or you just cannot hope to collect this kind of data. So you're always going to have, if you ever train a reward model, it's always going to have like gaps in its understanding. It's never going to be able to like correctly score everything, just because of the complexity of the problem, right? Okay, so we were like, we kind of like read, we're just kind of like aware of like what's going on in the field, and that gives us some understanding of what are the open problems. And like, okay, actually this problem, like the RL theory community has known how to solve for years and years. So we like had some basic ideas already for how to solve this.
So can you say what's RL theory?
Yeah, the reinforcement learning theory.
Okay,
yeah. Sorry. So I think we were like, oh, like here's like a easy way to solve this problem, and then we like turned that into like a palatable algorithm that you can implement and you can run to post-train language models.
So then your metric kind of for success is you publish a paper that solves an open problem, and then I guess do you sort of look for, is there a way to know like, oh, are people actually using this answer to the problem? Or how do you sort of see if the paper that you wrote, the research that you did became successful or was like good?
So one measure is like citations, or just like, it's more like academic impact. Are people building off your work? Are people coming to you and talking to you about your work? Stuff like this. It's harder to know what the industry labs are doing,
because they could use
it and they won't tell you.
You would never know. Yeah. Okay.
Yeah.
It's not like a GitHub thing where you can just like know how many people are using it.
Yeah. I mean, okay, we haven't released code for this, but like we could, and then we can see who's forking our repo, putting star, or whatever. You can see all these metrics, just like other open source things. Here, like we have teams who are training language models, so we can talk to them and we can say, hey, like we have this idea. We validated it on a small-ish model. Why don't you? Do you guys want to try it on a bigger model, right? And they're like pretty open to this actually. So we had another project that did sort of get tech transferred to a language model training team. And it was a very simple intervention, and they used it. It seemed to work well, you know.
Why is your company so open? Why is Microsoft so open about this? Or why is everyone so open about it? So why do they allow you to publish? I feel like it might feel natural to be like, this is our learning, like keep it all internal, like everyone's in their own race. And I view it as a good thing that you're publishing and that people are publishing, but I almost don't see it as natural that that's what would happen. Even DeepSeek, I'm like, why did they publish the paper? It seems like they should just keep all this stuff private.
I don't know. For Microsoft, I think it's like there's a history of doing this. Like Microsoft research has been around for like, I don't know, 40 years or something. And it's been a academic place primarily for that time. But you see a lot of the other companies are like, okay, my colleague says it's going dark. They're not publishing as much. And they actually have like some internal review about whether you can publish a paper.
Yeah, so they're also probably behind. Like they're not publishing the latest and greatest that they're now implementing today. They might publish something that they implemented a year ago, but it's still news to people, you know?
Exactly. Yeah. So we actually recently implemented one of these, and there was a huge uproar about it. And my concern was exactly this. Like there's a perception in the academic community. Like if people know that we're going through internal review, I think it's very reasonable for them to assume that the good ideas are not being published.
Yeah, the breakthroughs are being kept internal.
Breakthroughs are being kept internal.
And it's meant to slow down the rate of publishing.
Exactly. So I think like my coworkers think like when Google puts out a paper, it's like not an interesting one. That's like the prior, right? Because Google is basically dark. And Meta, they have a foundations team, like what used to be called FAIR, Facebook AI Research, is now like foundational AI research. And then there's like the generative AI team. The generative AI team doesn't publish very much. And the foundations team, I think it's just like, there's a sense in which it's like so far from the applications that like, it's okay to publish. Right.
For you, is it like
what are the benefits to them of publishing anything, would you say? Or even for you guys?
I think it's largely reputational. Like we use it to hire people. Right?
Yeah.
People see that Microsoft does good research. It's public information, right? And they kind of want to do that, right? And like nowadays, it seems like a lot of the AI talent that people are trying to attract are like PhDs. So they have this sort of like research mindset, and they're familiar with publishing papers and stuff like this, right? So,
yeah, that's sort of in a way what I was going to ask you, which is if they shut down your ability to publish, do you think personally you'd be more likely to say, I'm not as interested?
No, I'll probably leave.
You probably leave. That's what.
And
Yeah, to say it more pointedly, you'd probably leave. Yeah. Okay. So that's like, to put a fine point on it. They lose a ton of talent.
Yeah.
Okay.
So maybe it's also like, I don't know. The research people are these like, I don't know. They're very like independent, fiercely independent people, and like you have to give them this like weird environment to thrive. And if you don't give them that, they'll just be like, well, I'll go somewhere else because they think they're like amazing, right?
Or maybe it's also to say you're like a little more maybe techno-utopian or something, or techno-transparent in your mindset coming out of university. And then like you're like, look, this information should be shared. Otherwise, how are people going to build on it? And then I want someone else to build on it, and then I can do the next fun thing. And it's like, that's how you grow something.
Yeah, I mean, like I derive immense value from reading what other people are trying through their papers and stuff like this. So I feel like I should do the same, right? Like contribute back to the like broader scientific knowledge, right?
And I think like one thing I've learned, I previously didn't understand research at all. Like, why are people doing PhDs? Like, why are people doing all this research and publishing it? Like, what's so great about it? But there's this like shoulders of giants argument, right? Like you have to have that foundational forefront of research so that people can actually build practice. Because at the end of the day, like what you're working on is very deeply technical. And, you know, even in this conversation, I've had a tough time keeping the thread between, okay, what you're working on and like, what is that? How does that map to like reality, right? Like, what does that mean in the, like for a product? But there's you guys, and then there's like a layer of other people who understand the research, but are more engineering and product people who can then go and apply this cutting edge stuff. And that's not you guys. That's someone else. So I think that's the core unblock in my mind that I've had is like, okay, that's like those are different cohorts of people who spike on different things. But in order for us to have progress, you need to have every piece.
Yeah. Yeah. Like I think a lot of AI products are based on like technological innovation, which maybe the product people cannot do. Like you need like scientists to do it or something, right? And yeah.
So can I, do you mind if I go back to the third topic you were talking about? So you took pre-training.
Yeah.
And then you have post-training, which is sort of getting the model to exclude some of the things you don't want it to and focus on the reinforcement you do like. What
Yeah.
was the last
Yeah.
thing?
The third thing is like the new like hot thing, and it's called like inference time compute. And this will I'll tell you about another project we just did, which I'm excited about. Basically, what this is doing is like your model is like pre-trained, and you can ask it questions. But somehow, like, okay, maybe here's a better analogy. Sometimes when I give you like a hard problem, you can't just like blurt out the answer. Like you need to like do some computation to like, or you need to do some thinking in your head, or like consider various scenarios, you know, before you come to an answer. And it seems that this is basically true for these models as well. So you can add, so like there's a thing you can do. You can say like, I'm going to give you a math problem. The answer will be like some number. You must answer immediately. You're not allowed to write anything else. Okay, that's one way you can ask this question. And the other way is you can say, I'm going to give you a math problem. The answer will be a number. Feel free to show your work, write whatever you want, and then report the final answer. The performance for like all these models is much better the second way.
Wow.
Okay, so
like if I go into ChatGPT and try this,
yes,
it'll make a difference in
yes.
outcome. Okay.
Yes. Well, I mean, like you should do it over like a course of many examples.
Sure, but yeah.
Yeah, but yeah, this will be true for GPT. And
so
this is like
inference time compute.
Inference time compute. So when you ask the model questions, when it is doing inference, you give it the ability to do more computation through showing its work. There's many strategies, but one way is you just say, show your work. Okay. Then another way is like you do something internally where you like, when you're generating the sentence, you actually like don't just generate one word at a time. You sometimes go back, you like generate half, then you're like, oh, actually I made a mistake so far. So you go back and you try again and stuff like this, right? Remember, like the model produces this distribution of the next word given what it's seen so far. So you can say, let's take the most likely word, and then you can try this trajectory. Then you can come back and say, let's take the second most likely word and try this other trajectory. And so you can get different responses by like following different paths in this.
Kind of like tree depth for like a chess game or something.
Exactly.
You know, I've noticed this in Perplexity actually. Now I sort of switched to starting to try that, and it'll tell me, oh, I actually made a mistake.
Yeah.
I'm going to try it'll write that in the thing. I'm like, oh, that's so interesting. It's giving me its thought process as it's going through.
So yeah, so they call this backtracking. The model will produce something. It will say, actually, I made a mistake, and it will go back and will produce it. And it will just do this automatically, right? So these models you have to sort of train these models to backtrack. And that's like, so inference time compute is close to post-training. It's like, I know I'm going to use the model in this strange way. So I should train it so that it has the ability to do backtracking and trying multiple paths and stuff like this. Okay. Okay, so I can tell you a little bit about, so that's like what inference time compute is, like using more computational resources at the time the model is being asked questions. And there's many strategies.
What was the previous thing before this came about?
The previous thing is the model just outputs the answer.
Okay.
Yeah. And yeah, like I think this one where you show your work, this like, it's called chain of thought or Scratchpad, and people have been using it for a while, but somehow I guess O1, the like old OpenAI model, the second most recent OpenAI model, was trained on its own trajectories where it was doing some tree search. So you give it questions, it generates, and then you like run some algorithm to try many different paths in this like trees that you can produce. Like, at every time step, you can take one of the top 10 tokens, and you get some many options. You try many of these paths, and you train on the good ones.
Yeah, in a way, it's generating its own synthetic data right before the output comes out. So, what's the challenge that you were saying you're excited about something in this?
So we have a paper that sort of like gives some understanding for why this helps at all, and the high level reason is that like verifying that your answers are correct is much easier than generating your own answers. It's like computationally easier than generating your own answers. So
yeah, I mean, even if you think about it naturally from a human standpoint, It's a lot easier to come up with a first draft and then iterate than it is to come out with a pristine final draft.
Exactly. So this exact. I was thinking about this because we're writing a paper and we have this paragraph that we want to edit, and we have a draft of the paragraph, and we're like cutting the words, and it's getting better and better. And I'm like, but we wouldn't have been able to just produce. So it's exactly what you're saying. We wouldn't have been able to produce the final paragraph without writing something kind of bad first, right? Even humans need to do this, I guess, right? Like we cannot store enough information in our head to like just spit out correct answers.
It reminds me of The Hitchhiker's Guide to the Galaxy at the very end. If you're familiar with this book, they get to this prescient source and they're like, okay, so what's the meaning of life? And it's like 43.
42, I think.
42.
Oh, this guy's...
or 42. And it's like, okay, so that's the answer. But what I actually wanted to know is like, how did you get there?
Right.
Like that's more important.
Right. So this is also like, there's like a computer science theory formalization of this thing. So like, there's these problems where like, I can tell you if your answer is correct once you give me the answer, but you producing the answer is like computationally very hard. Right. I'm like, okay, I think one was like, some version of this is like, I want you to drive and hit every state in the country, but I want you to use the fewest miles possible.
Yeah, the traveler.
It's like
traveling salesman.
Traveling salesman problem is the name of this, right? So if you, or maybe I want you to drive and hit every state and use at most drive for only 3,000 miles, something like this. If you show me your route, I can check, does it hit every state? That's very easy to check, and I can just count all the miles. Is it, But to figure out what a good route is, I guess I'll just have to kind of like try them all, right? So generating a good answer is very, very hard, but checking if an answer is good is actually pretty easy. And so one way you can use this inference time compute, you generate lots of answers, and then you just like check if any of them are good, right? Mm-hmm. And maybe your own model has this ability. So like the paper that we did, you just generate 100 answers from your model. Like, you get this distribution, you just sample from the distribution. And every token, you just sample from the distribution, and you get a new distribution, you keep sampling. So all these responses will be different. And then you take your own model and you say, like, you prompt the model to say, is this response correct? Is this response correct? But you're just prompting your own model. There's no new information.
And you're judging it against the reward function that you put in for the post-processing?
So here I'm not doing that. So I take one model, whatever, GPT, and I say, generate 100 responses. Then I take GPT and I say, do you think this answer is correct? Do you, GPT, think this answer is correct?
Mm-hmm.
And then I select one of the ones that GPT thinks is correct. And then I check if that one is actually correct.
And that you find is much more accurate to do that.
That's better.
Interesting. Would it be even better if you asked a different neural net to do the check, because it's not the one generating? It's almost like I'm thinking of the way
a different model.
Viv's is thinking about it. Like if we're having a conversation, I give a bunch of answers, then I'm looking at my own answers. That might be worse than me asking you or Vivek, like, hey, which of these is a better answer?
I think that's correct. There's some like unbiasedness to having another person look or another model look. But I guess the point is the model can actually do this. Like even yourself, even one single model can get a lift by like checking its own responses. And this is, I guess, surprising because there's no new information. The model, the model has all the information it has. It's like if you put a model in a vacuum and you say produce an answer, and like somehow you say produce an answer in this way, it's better than you say produce an answer in this other way. But like the model had all the information.
Yeah, it didn't change the actual information that it had.
It didn't change the information content at all, right? It's a computational phenomenon. The model needs to do more computation to figure out to extract all the information it has. The standard way of just generating a response is not using enough computation.
So how long, it must be a math problem to figure out how long you should wait before delivering an answer. Like where does the asymptote get to the point where it's like, okay, it's not worth waiting anymore. I've done enough tree search generation. Is that, probably it's not the same answer for every question either, but I'm curious if will we just reach a point where it's like, okay, you've reached the right depth where now the answer refinement has gotten irrelevant. Now deliver the answer?
I think it's not known, or it's, I imagine it depends on the question, but I think it's not known. And I mean, you've probably seen this when you ask these models things, they output like 10,000 words and you just don't read it. Like, there's like one sentence in there that's all you really wanted, but they output like 10,000 words.
Mm-hmm.
So there is some open problem of it's kind of like a usability problem. The model does the right thing, sort of, but like you need to scan. You know, only one sentence
Yeah,
of
it's
these
just blabbering.
100 is correct,
Yeah.
right? Yeah. So I don't think they've like solved this problem, certainly, and I don't know what the like theoretical limit would be, right? There should be some like, this is all the information there is. If I gave you infinite compute, you still wouldn't solve all the math problems, I guess. But I don't think we've hit it or anything like that.
So one thing I actually wanted to, it's switching gears a little bit, but I wanted to ask you about is, it feels like the way that machine learning research works today is probably different to what machine learning research looked like before you had this reinforcement learning situation. Because like before that came about, it was probably like you were just writing every feature and writing every single thing. It wasn't like learning by itself by you feeding it information. Is that accurate? Okay.
I think that's kind of correct. I guess like maybe deep learning in general is like learning features in some sense. It is. I think it's true that like much more has been automated in some sense. So
yeah, because like it seems like the job to be done of the researcher is totally different, right?
Maybe that's, I would say the job of the data scientist is different. So I think the researcher, like for me, I think my job is approximately the same as what it was 10 years ago. I like examine what seems to be interesting problems that empiricists are facing. I try to like formulate them in a mathematical language. I try to come up with a new algorithm to like an algorithmic intervention to help solve their problem. And sometimes I do like an empirical validation of that. Right.
Wait, but let me take a step back, which is, isn't it different for you to get GPT to optimize itself versus in the past you were doing the
optimization,
presumably, right?
Yeah.
Isn't that like a completely different thing?
I think at some level of abstraction, no. It's like the problem domain is different, but I can abstract this to like I have an agent who is collecting information about the world and trying to improve its performance, which is actually what I was doing 10 years ago, right? It's just the agent is GPT-2 and its performance is measured according to GPT-2 or GPT-4, right? Like,
yeah,
it's just like who's the
in the previous,
and who's the reward.
Well,
right?
In the previous case, like you were creating the agent versus now the agent exists and you're trying to optimize it. Is that right?
Oh, I see. That's kind of true. So like I don't design like neural net architectures. I just like download, whatever, like Llama.
And previous
Hugging Face,
like you were saying, like there was a time period when there were haters. They're like, this neural net architecture isn't going to work. Like we're just going to have to engineer everything from scratch. Right. And like the neural net architecture is like on the shelf. And then at some point, this neural net architecture came about, and now everyone is surging towards, oh, we just got to train this thing rather than me writing everything. Is that true? Is that like accurate?
I think that's, yeah. So like there was a lot of work in like, what are good features for your problem back, I don't know, in 20 years ago.
Yeah.
And now there's like none of this. Maybe 10 years ago, there was like a ton of work on like, what are good neural network architectures?
Yeah.
For different problems.
But
like,
now that's converged sort of.
Now it's like basically everyone uses transformers. There is still some work in this area, but like it's very, very hard to break through because like this thing is like so good,
And the reason I even reference it is because like it seems to me that at least on model building, getting better models, like now it's not even the foundational model. It's like the DeepSeek. It's like, how do you optimize this thing?
Yeah.
That's already like doing this. So the model's there, the architecture's there, the model's there, you know how to train it, all this stuff, but how do you do it more efficiently? And that's the phase of research that we're sort of, not research, that's the phase of like where we're at in terms of...
That's definitely a big part of it. DeepSeek has some architectural things that are cool, I guess.
Okay.
But yeah, it's like, they're all basically these like transformer style networks with some bells and whistles and stuff like that.
Like, just to ask about the DeepSeek thing, just what is it about DeepSeek that you find interesting, like academically or algorithmically?
Okay, so I read the DeepSeek, there's like two tech reports. One is like, what is the pre-trained model? And then what is the like RL fine tuning? Okay, so we talked about both these things, so you kind of know what those are. So the RL fine tuning thing is what made a big splash. But it seems to me like in terms of the cost savings, it's actually the pre-trained model is where all the savings are. The RL fine, yeah, go ahead.
Is that where you were saying they pre-trained on the GPT-4 outputs probably, or like some refined synthetic data outputs, and that's the savings? Okay.
Yeah.
But they didn't say that. It was just more that
I actually didn't read their other paper, but like I've talked about it with some people. I think that might be where they get some savings, but they also seem to have like done some like crazy engineering tricks that are like saving them. Their model's smaller. And okay, so the one trick that I know is a lot of these models, they have this architectural thing called a mixture of experts. So it's slightly due to like hardware constraints. You cannot put like 1 trillion parameters on one GPU. It just doesn't fit. Okay. So what you do is you actually shard your model into like 8 blocks of whatever, like 1/8 trillion parameters each. And then you put like only one shard on the GPU at a time. Okay. And so what this means is that each like token is routed not through all the parameters, but just through like a fraction of the parameters, through one expert. Okay.
Sorry, so what is a parameter? It's like a word or like a
no. Okay. So okay, you can visualize what a neuron is, right? So like it takes in a signal and then it like produces a signal.
Yeah.
Okay. So or maybe it takes in many signals and produces one number out. And you take in many signals, these are just like numbers, and you compute like a combination of these numbers by like multiplying them by some numbers also. So your neuron is storing, like maybe the neuron takes in 10 numbers. The neuron is storing 10 numbers itself. Those are its parameters. And it takes a linear combination of these 10 guys and then spits it out.
Got it. Okay. And it passes it to the next one.
Passes it to the next
one. Got it.
So
okay.
That's like what that's like what a parameter is.
Got it. Okay.
So the neural network, the function it computes or the like behavior is derived by the parameters. The architecture is just like, where do the edges go? Who's the next guy I route to? But what I route is determined by who routes, what people route to me and my parameters.
And the more parameters you have the more parameters you're passing, the more I can describe the world, or the more I can describe the thing that I'm looking at.
That's the idea. Yeah.
Roughly
speaking. Roughly, you need more parameters to model more complex phenomena.
Got it. Okay.
So by sharding all of them, what?
So they have made the number of shards much wider, so you can use much smaller GPUs. So like,
okay.
I think their model is like 600 million parameters, but they've sharded it into 128 shards. So each one is using whatever, like 6 million parameters or something.
But then wouldn't that make it a little slower though, or something? Because like,
yeah, go ahead.
Like, imagine you have all in one monolithic GPU somehow. It would be able to be faster to give you back an answer versus you pass it through like 128 different machines. Is that slower or something?
Yeah. So I guess the point of mixture of experts is you don't pass it through all 128. You pass it through one. So every
then
token,
won't it be less accurate?
Yeah. So every token, but no. So yeah. So every token is routed through one, but there's a router who decides which shard to route each token. So it's like the shards are developing expertise.
The router is like an index. It like knows where.
Yeah, the router like knows who's the expert in math and who's the expert in history, and it routes to that expert. That's why it's called a mixture.
Yeah. I'm almost thinking of it like a checkout line at a grocery store or something, and someone's like, "Okay, you go to that lane. You go to that lane," and it's based on you're buying a lot of fruit, or you're buying less than 10 items, you're buying more than 20 items.
Exactly.
And that seems like a really cool breakthrough.
Yeah. And I think there's I actually don't know how they did it, but there's some like engineering, like conceptually, there's no reason you couldn't just like shard as much as you want. And it does seem like you lose something because then more and more like statistical demand is put on the router.
Yeah.
Right. Like as you specialize more and more of the experts, you're like, well, the router better know, like you see the token, you need to know which like topic it's about, which is kind of hard. Right. So I don't, there seems to be some statistical limit. I don't think that's what's being hit here. It's like some engineering thing that they managed to figure out.
And that actually is driving costs down.
I think so.
Because they can use older versions of the GPU, or they don't need the most sophisticated.
They use older GPUs and stuff like that.
Okay, so actually now I get why there's like a direct attack on NVIDIA in a way, or there could be. Because people could say, well, maybe I just need to build a really good router. Maybe that becomes the key thing, the router layer.
And then you can run it on a toaster.
I'm actually already good.
Yeah.
Yeah, I was thinking earlier, Vivs, we need to have you, like the Obama anger translator that they did, the Key and Peele thing. We need to have you as like the AI translator where Akshay will say something and you'll be like, yeah, it's just like getting a girl, it's just like, Can I add? Okay, go ahead. Keep going. Sorry.
So yeah, the DeepSeek, the like R1, the RL thing, I think it's kind of cool, but I think it's a little bit of hype. Like I don't think they're doing it. Like basically everyone is already trying to do this, and I don't think they've like unlocked something particularly new in how to do this like RL style training. And indeed, there's like the day after the DeepSeek thing came out, like one group started trying to replicate, and one group was like, "We actually were already doing this, and here's our results."
Oh, interesting.
So yeah,
the router thing wasn't like a DeepSeek finding. They've kind of using literature.
Not the router. I mean the reinforcement learning part. So the pre-trained model uses this mixture of experts with the router. The post-trained model, which is this DeepSeek R1, takes the pre-trained model and does something else using reinforcement learning.
Okay.
And I think that was the thing that like made a big splash. But I think it mostly the splash is mostly due to the like dollar efficiency of training the whole thing, not due to like its capabilities. Or maybe it's a combination. Like the capabilities are pretty good and the dollar efficiency is extremely low. Right. But the dollar efficiency is coming from the pre-training is what I understand.
Yeah. And another like big buzz thing about it is that like, you know, a lot of people were like very skeptical because it's like it's from China, like all this stuff. Basically, technically, they don't even have access to NVIDIA GPUs in China or something. But they still get them through Singapore or whatever.
Or the dark web.
Yeah. Yes. So they could be. A lot of people were saying, "Oh, they might just be lying," or something like that.
That's true. It's possible. Yeah,
it's possible. But like, yeah, I guess you don't know what to believe. But
yeah.
What do you think? Oh, go ahead. I was going to ask, what do you think the next? Like you mentioned the router kind of thing. Like you're sitting at the edge of the technical landscape. Is there another leap? Sort of. I feel like inference time compute is like as a third layer, another leap. Sounds like routers maybe a different type of leap. Are you seeing like something that's coming along, like maybe adversarial training or synthetic data or something like that? It's like almost like a categorical change that's going to happen?
I'm not sure. It's a little hard to predict. So the rumor has it that scaling at pre-training is not getting more mileage. So I guess there's been many attempts to train models bigger than GPT-4 and it's not worked, including at OpenAI. They're not.
That's based on some benchmark tests and stuff.
Yeah. So it seems like the new place to get better capabilities is like inference time compute. I think the thing that we're excited about is like using inference time compute very deliberately. So like, you know, the thing I told you, you just generate like a bunch of responses by sampling from the distribution. This actually seems kind of wasteful because you will imagine that like you might generate lots of like roughly the same thing, right? Like you'll produce a response and then you'll produce a response with like a synonym instead of the other word. Semantically, you're producing the same information. And maybe what you really want is to somehow enforce diversity in the way you're doing the generations so that like you make sure you hit all the possibilities of your solution space. So like we're excited to try like to do exploration, like get your model to be very deliberate about trying new things that it has not tried before and do that at inference time compute to try to get better performance. And that maybe can unlock something. I don't know, right? That's like what we're kind of excited about.
I'm not sure I 100% followed. I feel like you're saying basically the way that you do your inference time compute is often to compare a lot of similar answers to each other.
It's just the way
it ends up happening. But there might be a way to do it where you're actually getting more breadth of answers.
Yeah.
In a way that helps you to spread out and diversify the responses and get you like a better sort of triangulation to the right answer.
I don't know if you've tried this kind of thing with these models, but if you say like, hey, can you like help me plan a vacation? And it will say, oh yeah, well, you should try to go to like, I don't know, Tahoe. And then you say, actually, I didn't really want to go to Tahoe. Can you give me another place? And it will say, like, yeah, you should try to go to Tahoe again. You know, somehow it's like so locked into like what it. So when you say, can you give me a diverse response? It should give you something it hasn't given you before. This is the kind of thing that like, I think this stuff happens a lot. If you ask the math questions and you say, generate 100 responses just by sampling from your implied distribution, 95 of them will be about the same. And the like work, like the steps in the math will be the same also, but like the text around it will be like slightly different.
I see that even with just like, you know, write me an email, write it a different way, whatever. It's like
they're very similar. They're like semantically the same, right? And like
My thought, this whole conversation, I feel like actually this is a space that feels like you can make analogies to real life, and they actually are often like, oh yeah, with people, like this is kind of the way it works. And it's actually doesn't feel like that's so wrong often. It feels like it's kind of maybe like, oh, there's analogies that work. It feels like to me there'll be some point at which it'll be beneficial for the models to talk to each other. Like
Mhm.
the way that we're talking now. It's not that I'm going to change my personality entirely based on this conversation, but it's informing
Well,
something
I
about
am.
what
I'm
I'm going to
changing
say
my
next.
entire.
Yeah.
We've been waiting for it, Vince.
Well, yeah.
I'm excited for the no. So like, I feel like there's probably it feels like to me there'll be some unlock. This is totally unscientific, of course. I have no idea, but like, yeah, I don't know if
So
that's a thing that people study or not, but
I think there's this thing about like agents that people are excited about, which is this. It's like getting models to like do things on your behalf, like actually like navigate the world or navigate the virtual world on your behalf. Like I should be able to get an agent to like trade stocks for me and like incorporate my sense of risk and all these things and like don't do things that I
this
would
is
imagine are crazy, right?
all the rage right now. Yeah.
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 And I think some of these are like I think everyone should have an agent that responds to their email and the agents will just talk to each other. Like what's going to happen? I send you an email, but it's my agent, and then like you send me an email back, and we just never read them at all.
And
Like
you view this as a good thing. This is a good future.
well, I think some emails are not like worth my time to read.
Yeah,
right?
like
Yeah.
Or respond to.
scheduling, for
Scheduling,
example.
like scheduling
It's
is an insane problem. That's like I have a coworker. She's like pretty high up in the company. She says I spend one full day a week doing scheduling.
oh
One
my
full
God.
day a week.
Yeah.
And I'm
Wow.
like, that is such an inefficient use of your time, right?
And I mean, in sales, it's like the whole job almost.
Yeah,
Yeah,
Yeah.
the AI should like pop its head out and be like, "Hey, I need a little input from you,"
exactly.
and then it should pop its head back down
Yeah.
and do all the like back and forth, and then like pop its head back down and be like, that would be ideal." Yeah.
You can imagine like every morning your AI assistant is like, hey, I need you to answer 5 questions for me. And you answer those 5 questions and then that's it.
Yeah. Yeah.
All
Are
your
you busy at
calendar
this
is set.
time or whatever?
Yeah.
Yeah. That sounds like a great. So
Yeah.
sorry, you were saying that in the context of this is where it's going. You think? And the
I think
agents
this,
are going to talk to
yeah,
each other, and the AIs are going to talk to each other.
I think some of this is true. I also like, like this mixture of experts thing. I kind of think it would be really cool to see if like you can train like how like a company works. It's like the CEO has like all the information and like delegates tasks to certain people who delegate to certain people, and the CEO makes a decision about like who gets it, right? And somehow that's not the way like most of these architectures work, right? They're like
That's also not true, fundamentally.
but, well, I'm sure, but like
It's really knows what's happening,
dude.
you know what I'm saying? It's like everyone has like expertise, and like someone knows how to like route questions or how to route tasks to people based on their expertise, right?
Yeah.
And
Delegation powers, right?
it's not like there's one monolithic agent who like does everything.
Answers everything. Yeah.
You could argue that the organization is an agent, but I think there's some benefit in like not passing around like we have to communicate through text. Text has some like regularizing quality, or like has some I don't tell you everything in my head. I tell you the things that like are relevant for you to proceed in your part of the task. And that is some way that maybe makes the agents actually better.
Actually, even in the analogy you had before of scheduling, we had to schedule this call. We scheduled one for last week. It didn't work. So imagine agents were doing it for us. The agent would be like, hey, Akshay, looks like you have a conflict. Which one do you want to do? And which one should I bump to the next time? And so you'd have to give some input.
Sure.
And then maybe eventually it like knows which one you would prioritize or something.
Yeah.
Or maybe it never knows. Maybe you should do that. A human needs to be in the loop for that situation.
But I love the idea of like, let's say DeepSeek is sharding its data already and using a router. Like I would love the idea of like 50 or 100 DeepSeeks that have all been trained differently slightly. And
exactly.
like a super router.
Exactly.
That's like I'm typing and it's choosing the model, and then the model is choosing the submodel. And you might be able to do that for less money actually than they're training these big models, because DeepSeek's training for so much less.
Yeah. And like as a society, we have like not just one super router. It's like a multiple levels of hierarchy, right? It's like whatever, I'm like 8 layers deep in this company because whatever, right? But like, that's just like one, there's a super router who's the CEO, who's routing to the CTO, who's routing to whoever, who's routing to who tells me to do something, right? Like it's not just like the mixture of experts, I think is basically just one layer.
Mm-hmm.
But a large society that can, I don't know, do all the science that we've done didn't do it like that, right? Like it was much more like
Yeah.
Like,
So
hierarchical. Yeah.
Go ahead.
Viv. Oh, I was going to change subject slightly, which is I did want to ask you, like, when we were in college, I made this bet with you that we would have robots programming other robots in the next 100 years.
That's already happening.
It's basically happening. I mean, it's getting
I think
there.
I basically lost this one. Yeah.
I think you lost a bet, but that's that part. We don't need to settle a bet here. I was more curious, like, to me, that always felt like a bad outcome, like for society. It always felt like that would be a very dangerous outcome. Let me say it that way.
Mm-hmm.
Very uncontrollable outcome. So you're obviously working to further this. I'm not necessarily trying to say you have to think about the ethics of this every day that you're in the job, but I'm more curious, like, do you feel strongly one way or the other, like this is going to be a force for good? This is going to end up on the side of being controllable and helpful to humans? Or is it like, hey, this progress just has to happen. It's going to happen. It's intellectually interesting. I'm not necessarily the one who has to decide ethically where it goes. I'm hopeful it's positive, but I just like, it's more of an interesting problem that I'm working on.
I think it's a little bit more of the latter. I do think this is, I mean, at this stage, it's basically inevitable, right?
Mm-hmm.
Like you cannot stop progress, whatever that means, right? Like it's just like not possible to do that. I do think it's like, okay, I do think it's very important to figure out like what's going to happen. Like even just in terms of jobs, like, programming is like pretty easy now, like you just have a co-pilot and it just like writes 80% of your code for you, right?
Mm-hmm.
So like, that's actually like my job is the one that's being displaced. We thought like the scientists would be the ones who last, but that's not the case, right?
Mm-hmm. We thought there's going to be a bunch of humanoid robots that are building cars, which is also happening in some ways, but the real jobs that are being displaced are like white collar ones.
White collar jobs. Yeah. Like actually the thing that's slower is the robotics. Like we're bad at manipulating the physical world. We're extremely good at manipulating the virtual world, right? So people who send emails to each other, it's like some AI should just do it, right? So I don't know what's going to happen. Maybe we can all just be artists or something. I don't know, right? Like it seems like there should be like,
it sounds like you may have listened to our, did you listen to our previous pod by any chance? Shameless plug to listen to our.
You're plugging to your like current listeners to listen to the.
Well, yeah, not everyone's listened to everything.
Okay.
In fact, I know for a fact that not everyone's listened to everything.
Well, usually you do this with like cross pods. It's like we have a channel with many pods, and then you say like, oh, if you like this one, you should go listen to the other one by my.
We're going to shard this pod into 20 smaller pods.
Yeah,
and then
this pod is going to be sharded for sure. There's one more topic. I know if Arvind may have to leave
I have
soon.
to go in less than 5 minutes.
Okay, but I have one topic I wanted to cover with you, which is, I think a big question. It's a sort of an elephant in the room, which is like, what about the energy level? Like, how much energy is all this taking? Obviously, there's
a lot.
Do you think about that at all in your day to day? Like
Yeah.
how much? Like what does this mean for how much? Like is this if I need a bot to send emails for me all day, like how much energy is it going to consume? Is it going to take 4 slices of pizza worth of energy? That's how much a regular human would take.
This is your unit of energy. Slices of pizza.
Yeah, I mean, I think like some of the stuff that I do, which is like trying to make models better, you could argue it's like trying to make smaller models as good as the big models. So it's actually kind of like trying to improve the energy side of things. Like that's this one interpretation. It seems like maybe both with like hardware advance, like maybe the energy part is like, this is where we are right now. And most people do not need like a GPT-5 scale model to write emails. You should be able to get away with a much, much smaller model, right? So that's the thing I was like kind of confused about. Like everyone now is like really obsessed with this reasoning stuff, but like for 99% of like use cases, it's just like not necessary.
Right. You don't need like the Google deep. You guys have, I mean, OpenAI has the same thing now. They just launched it yesterday or something.
You just don't need it.
The deep research where it goes and does a deep research on a topic. You need that for very few things. Like what you really need is like reply to this email or schedule my calendar for me.
I think most like consumer and even like enterprise applications will not actually require a very large model, right? Now the energy cost will still be like high, I guess, right? But I think we can also bring it down to some extent. Like even DeepSeek is like, we trained a pretty small model to have very good performance. So maybe you can train a even smaller model to have, something like this, right?
Because it feels like the AI and crypto both are high energy sucking sort of areas.
Isn't crypto worse actually? I don't know the statistics.
Yeah,
I think it's worse.
They were saying like there's like
you should be discussing this with Jan.
We didn't confront Janth about this. We didn't get into this. I'd be curious his answer, actually, if he would care or not. But
it warrants a second episode. But yeah,
it does warrant a second episode. Yeah.
What are your, as one of the people who's on the forefront of the research, and I think you sort of lean leftly towards climate change type of stuff. Like, what's your thought process around the energy?
My mom has a friend, I guess, who works at OpenAI who has a theory about this, which is that the AI will help solve like nuclear fission, and then that will solve the energy problem. You use the deep research AI to find a solution to this, and then you get energy.
That's very meta. Okay.
Yeah.
I mean, it's a little like a plane taking off, right? That's the argument they're making. Is they're saying, okay, you're burning a ton of fuel now, but you're getting faster and faster, and the plane will take off before it hits the end of the runway. That's the argument.
Yeah.
Now, like whether it does or not, let's see.
Yeah.
Yeah.
Cool. I don't have a good answer. That's an interesting opinion, I guess. Yeah.
All right. I gotta get going. By the way, this was super elucidating.
Awesome,
yeah.
What a fun.
Did I answer all your questions?
Yeah, I think you did.
Okay.
And I think we should have a beer sometime and have. Yeah, we have some nice snippets that we can pull about some of this stuff, which is good.
No, but I do genuinely think this. I mean, for me, I didn't understand the layers and like especially like getting to inference time, compute, post training, that kind of thing. So it was super interesting. I mean, I now feel like I can go read the internet, and when they say like, I can get deeper on this now. Yeah.
Let me add one more thing. These things are super easy to play with. So like the tooling around these language models is insanely easy. You can just like, okay, if you have a GPU, you can download a model and like ask it questions on your own, not like use the web app.
And when you say if you have a GPU, everyone that has a laptop essentially has a GPU.
I think you should have one. And then you can just play with it. So you can like ask them like math problems and see if they do well. So like this thing about like, if they do self-verification and they do better, you can just run that experiment yourself. It's very, very easy to do.
Sorry, just walk me through. How would I do that? So I go to like Llama or something.
No, you go to huggingface.com.
Okay.
And you search for a model like Llama, and you search for a data set. Like there's a data set called math, and you just take it. Okay. And Hugging Face is like, here's how you download a model. Here's how you download a data set. And then there's just some like, there's like query. You query the model with the question. It's very, very simple. I can show you like over a beer or something. It's extremely easy. So the barrier. I mean,
if you want to stay on with Vivs for a second, you can show Vivs on screen share right now.
Yeah. Like the barrier to entry or to playing is like really, really low.
Are you actually down to show them? Because I'll just drop and then you guys can just show them real quick. Because that could actually be I would love to see that.
Also, the share screen functionality in the past has caused people to have to leave and come back.
Okay.
Just see if it works. If not, I got to drop. But this was super, super interesting. But thanks, man. Yeah.
Okay.
All right. Bye, Arv. We're going to continue the convo.
Yeah.
We're going to do the 5-hour Joe Rogan.
We're going to continue the convo. I have to prepare a little bit.
Okay, yeah, that's fine. We can edit anything out in post.
Okay. Well, okay, I can sort of show you this, but like, it's not going to be as clean as like, because I have written some like wrapper code to make this a bit better.
Mm-hmm.
Maybe
you wrote some code like Lil Wayne, like wrapper code.
Yeah, I maybe don't want to show people my code, but like,
I think you missed my joke.
Yeah. Where's the model? Okay. Do you really want to see this? I can show it to you.
I mean, we don't know. I mean, anything you show also we can remove or edit or whatever. So whatever you want.
Okay. So let me share screen.
It's might yell at you to. Oh yeah.
Oh my God. Okay.
Yeah, it works.
Okay. So like basically like.
Maybe zoom in a little bit. If you can.
How do I do that?
Yeah.
So there's this like library called VLLM. Okay.
Mm-hmm.
And this is how you like get a language model. This is like downloading a language model. And the language model is named like Microsoft /Phi3 Mini 4K Instruct. Like that's the name of the model.
Mm-hmm.
And what I'm doing here is I'm going to like Hugging. What just happened?
There you go.
So you go to Hugging Face.
For those who don't know, what is Hugging Face?
Hugging Face is just like a place for people to store models and data sets. It's another AI company.
Yeah.
And they just like allow you to store all this stuff. And they provide code for you to play with it. So their code is like what is powering like my research, in some sense.
Wait, so this would be a way for you to, if people use your model, then you'll know about it, right? We were talking about this earlier.
So if I uploaded a model here, then you can do that. You can check.
Okay.
Right. So this is a model that like, I guess some of my friends at Microsoft made.
Mm-hmm.
And they uploaded it here, and you can just download it. Okay. And you just download it by like running this one line. That's it.
Okay.
Okay. And you put this name over here.
Mm-hmm.
That's it. Okay.
So now you have it in your laptop has it, basically.
My laptop, yeah, it will be put on my GPU.
Yeah.
Okay. And then, okay, there's some like annoying stuff about like, getting whatever, but like, this is how you do generate. You say like, you call your model. That's my model. You say generate, and you say, here's the prompt I want you to generate. And here's some like parameters that I want you to use when you're sampling.
Mhm.
Like, how should you generate 100 responses or one response? How exactly should you do the generation? That's it. That's the response. That's all you have to do. It's like 2 lines of code
That's awesome.
to get a model and ask it questions.
That's amazing. Okay. So how do you ask it something? I mean, you know this model and I don't. So is it like a math thing or what is it?
I asked it math questions. Let me show you some questions I asked some model. What are the questions? I actually don't know the questions. But here's the responses.
Okay, here we go.
Okay. Yeah. So this is, I ran some experiment. There's a data set called grade school math. It's like 8,000 questions, GSM 8K. This is Google's like mini Gemini model, Gemma. Okay. I asked it some question. The question is something like, okay, what's the question? So you can also download data sets from Hugging Face. It's
So can you like do this with, I don't know. You can't do this with like DeepSeek or something. That's too big, right?
That's probably too big.
Yeah.
So this is the question. Janet's ducks lay 16 eggs per day. She eats 3 for breakfast. She bakes muffins with 4. She sells the remainder. How much does she make? Okay, this is a question. It's like some very simple math question. And I asked this model this question, and I asked it to generate 32 different responses. Let me just show you the first one. This is the first response. Here's how to solve the problem step by step. 1, calculate the number of eggs left after Janet eats some.
So it's showing its work. This is it showing its work.
This is the scratch pad. Yeah, the chain of thought. Okay, so it's just write some stuff, some nonsense, blah, 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 blah. And then it says the final answer is 18, which I believe is correct for this question. So you can do this, right?
Yeah. Anyone can play around with it, is what you're saying.
Anyone can play. It's very, very easy if you have a GPU.
And this is what people are like on X or Twitter, whatever, and they're like, oh yeah, I played with the model, and it's like so amazing, and here are all the things that I did. And this is what people are doing.
How do I stop
something
sharing? So I think there's 2 things. So some is like people just play with the web API.
Oh yeah, because people just publish it on a website. Yeah.
And then some is like, so like for OpenAI models, they never like release them like this.
Right, because it's like, proprietary.
Yeah. So these are like for the open source ones. And then, but a lot of people just play with the web API, and then some like will download and do other stuff, right?
So how good is the open source getting nowadays? Because Llama is an open source thing. People say that eventually, even if you're like a business, you might just get the open source one and tune it to do what you want versus paying a lot of money for a model that OpenAI is creating.
Totally. Yeah. I think that's correct. I mean, DeepSeek is open source in some sense. You can download the model yourself.
Okay.
They don't release their code, but they do release their model.
Oh, okay. So can you explain the difference?
Yeah. The model is just the settings of the parameters found by their code. Okay. So like the code, what it does is it trains a model and it finds a choice of parameters for their architecture.
Okay.
You can just save all the like the numbers, the parameters, and you can just give that to someone. That's your model. But I didn't tell you how I found that set of parameters.
Oh yeah. The code is helping you actually get to the end output.
Exactly.
But you can share the output, but the code is the code is the money. Like it's like, or the code is the important part, which is like how they got there. If you wanted to recreate it.
If you wanted to recreate, yeah. But if you want to use it as a product, like I am playing with Llama, but I'm not looking at the code. I'm downloading the model and asking it questions. Right.
And that's what they mean when they release a new version of Llama or GPT-4 or whatever. They've done a bunch of training and other things to get to this new model. Right. You can see the model. You can't see how they got there.
Right.
Got it.
Yeah. So now there's this like, is it fully open source or is it just like open model? That's like, there's a difference. So like some companies actually release fully open source. They release all their code. They release the data they use to train the code. They do all of this. And some companies do not do
just out of the goodness of their heart, or wow,
I guess
who are the models?
They're mostly like research labs. So like AI2 does this, but that's like a research lab.
AI2 is a research lab. Okay, got it.
It's a nonprofit. Yeah.
Okay.
Yeah. So it's a place like that. And then there's the places where like they only provide you their like API. Like you cannot download the weights at all. You can only access the model through the web or whatever, right?
What does it mean download the weights at all?
That's what I just did. I downloaded the weights.
Okay, so there's some that you can't download the weights. You can only hit the API and get a response.
You can only hit the API. Yeah.
Okay.
And the API also only doesn't provide it doesn't provide everything, right? It doesn't provide the weights. But like sometimes if you want to do this inference time compute, you need to see like the distribution of next tokens and like what probability is being assigned to each token. And some APIs like do not provide this information. So
when you're doing your research, you would want to do these tests on some, the models where they're providing everything. Is that right?
That's
ideally,
or
because then
we need some access, like some more than zero. We need some access. I think basically more than like what OpenAI usually gives.
Yeah, got it.
Yeah,
we can always edit whatever, but like, do you want to comment at all around OpenAI? You're at Microsoft Research. OpenAI is a company that is separate, but Microsoft has some access to them in some way, some access to their stuff. Like, what does that mean to you as an individual at Microsoft Research?
It seems like our access is pretty bad. Maybe that's just like the
say it another way. Do you have a different set of access than just a layperson that's doing research?
Basically, no. That's me. So some people at Microsoft are like, it's called tented. They're like in a group that works very closely with OpenAI, and they're given special access. They're signing an additional NDA.
It's sort of like it's G14 classified.
Exactly.
Right?
Yeah. Okay. Yeah. I don't know what that means, but yeah.
It's a really bad Rush Hour reference, but yeah.
Oh, I see. Yeah. So my access, basically, like my boss pays for an OpenAI account, and I can use that. So I just get it.
So you have the same access. If I were to go pay for an OpenAI account, I could
pretty
do it
much. Too. Yeah.
Okay. Not much different.
Yeah, like we host models, and I have the ability to like ping that model through the API.
And then, but some folks at Microsoft have some extra special access.
I think some folks have extra, especially the ones who are working very closely with them, because we host their models. So I think we have people
it's Azure,
who are working.
Right?
Yeah, we have people who are working on putting them in Azure, and I guess they must have some access, more access, right? And I think we have like people who are like building products that or like integrating OpenAI models into Microsoft products, right? Like maybe our Copilot is actually powered by OpenAI. It's not powered by our own model.
And like Microsoft has, I don't know if it's OpenAI, but I know like even the Office suite has some helpers that are doing some random things. So like PowerPoint can design your slides and stuff like that. Yeah.
Right. But I guess our access is maybe so. Like if you want to like do research, you want to like hit the API like many times. I want to ask, this data set has 8,000 questions. I want to ask all 8,000 questions. So I need to ping the API 8,000 times. If you are like a layperson, you will hit like some rate limit. You don't want to overflow them. So we have a pretty good rate limit, I guess.
Okay. So that's one unblock that you guys have.
That's one advantage, I guess. Yeah.
Okay.
Yeah.
Cool.
But I think most other places like they just pay for many subscriptions. And so they can like overcome the rate limit through money, right?
Yeah, because then they have multiple API keys, and
they have multiple API keys, and they just like cycle through them or something.
Yeah. Money solves a lot of this stuff.
Yes, yes. We also have like not the best GPU infrastructure. Like
Azure or
no, like a lot of our GPUs are like Microsoft is investing very very heavily in GPUs as it makes sense, but they're using them for OpenAI. So
they're basically giving it to them.
They're basically giving them like they're using the GPUs to host the OpenAI models to serve customers.
Would there be a good? Would you ever want to work for OpenAI instead, or are you pretty comfortable where you're at?
I think likely no. I think it kind of depends on how it goes, but like I kind of like having independence. I kind of like doing things for like scientific purposes.
Because if you go there, they're more closed. Like what were you calling it? Dark spot or something, right?
Dark, yeah.
They're
just dark.
They're just dark.
Yeah, yeah. They've gone dark. Yeah,
they've gone dark. Okay.
And I think it's like I just like philosophically, I am like more interested in like understanding what's going on than like I don't know, building the, finding
Building
the next
the product.
breakthrough, right? Yeah. So, but I think there are people there who are doing it. I mean, they have extremely talented researchers who are doing the stuff. And so it's just like not exactly what I want to do.
Yeah, makes sense. Makes sense.
Yeah.
The dark thing makes total sense because it's like you're more, as we talked about earlier in this conversation, you have more of a ethos around research and publications and sharing what you're doing. So that would kind of almost disqualify that type of a company if you had to keep that that same level of transparency with what you're working on.
Yeah, but somehow I feel like they end up getting lots of things leaked. So I don't know. Like it's just like the way in which the information is disclosed is different, but the information is like disclosed.
It still gets out somehow.
It's still disclosed. Yeah. But I also kind of like the process of writing a paper. It's like good to like crystallize. It's like good for checkpointing. It's like we did this thing and like we're happy with it.
Yeah, and it's like peer reviewed and stuff like that.
Yeah. And it's so I quite like that. I mean, I guess it's basically I've been doing it for 15 years.
For so long,
Yeah, it's very comfortable, I guess. So,
well, dude, this has been a super enlightening conversation. Like, I think I learned more than, you should probably charge me.
Okay. Well, I owe Arvin $1,000, so you can.
Yeah, because you guys had a bet to see if in the next 100 years if a computer could code.
I think it was 50 years, and I think that I don't remember the exact. It was something like it was something about AI and whether it would build another AI.
Yeah.
Can an AI build another AI of like?
Right.
I actually don't think we're there. Like we haven't hit this. They call it like super intelligence. Mm-hmm. So you need the AI to like train an AI that is better than itself. Right.
Well, that's
so because that's how you can.
I mean, I think the semantics matter here. You have to go back to what was the original bet.
So that I don't know, but I think I'm probably gonna lose because it was like 50 years. It's been 15,
it's not even close.
It's like not even close. So I think people and I think some people believe that this will happen, but we'll see. I think we'll probably need some breakthroughs for that.
Yeah.
Yeah.
Okay, cool. Well, we'll talk soon, and
thanks, dude.
We'll share the clips. We want to make this good for you too. So if there's any publications you want to share with people or links that you want to include and stuff like that, like we'll put them in.
We're actually gonna write. I'm writing a blog post that's gonna go onto some like learning theory blog.
Yeah.
About the first project I talked about, this like combating over optimization.
Got it. So
okay. I can. It should be published next week.
All right.
We have a deadline tomorrow, so like we're delaying a bit.
We're probably going to publish this episode in a week or so. So we'll have the links.
So I can try to link to that one. Yeah.
All right. Awesome, man. Hey, thanks for joining us.
This is very fun, actually.
Yeah, this was fun, right?
Yeah, for sure.
Okay, cool.
Yeah.
We'll do it again.
Okay.
Yeah. Okay.
Okay, sounds good. Right. We can talk about rock climbing.
Yeah.
Or frisbee. Yeah.
All right.
Okay.
Different type of training, but yeah. Okay.
Different training. Yeah. All right. Bye.
Bye.